This is something I've wanted to make for a long time, a deep dive into how Doomlike Dungeons actually works and generates its dungeons. It's also, to a large extent, how Caverns of Evil works, because it uses essentially the same system to generate its level geometry. Please forgive the fact that I have a cheap microphone and may not necessarily be the best presenter as far as my vocal presentation, and also the fact that for some reason Impress will not do a true full screen mode. It always wants to show the title at the top. So it basically keeps the title per window, even though it's supposed to be full screen. But anyway, and by the way, I am using this slideshow format because certain things are just easier to show than to try and just explain it and talk around it. There are a lot of things that aren't that complicated or difficult to understand if I can just show you, but might sound more confusing than they are if I'm trying to talk myself around it. So I do have pictures and animations, and that's why I'm using this slideshow format. But as far as my goals I had when I started working on it, I wanted them to be highly varied in terms of both layout and style, including the ability to have numerous themes and for the themes to be easily modifiable. So you could mod the mod, so to speak. I wanted to have levels or dungeons that were non-linear, both in terms of being branching, but also in terms of having lots of loops where you go around in circles and go one way and come back to where you started in a different way. I didn't want it to be just like a branching tree with lots of dead ends. I wanted it to loop around instead of having dead ends everywhere. Of course, I want it to be fun and reasonably challenging and reasonably rewarding. And very importantly, I said from the beginning that my goal was essentially to create something that would generate dungeons with a quality level comparable to a mediocre human level designer. I did not have any expectations that it would be able to compare to what you could get from a talented, creative level designer. I often said that it is not trying to create a robot John Romero or a robot American McGee. It's not trying to be the equivalent of a talented, creative level designer like that. But some humans also make terrible levels, and I definitely wanted it to be better than that, and I was sure I could be. So, something that is fun, entertaining, not necessarily planned out and deep or having a lot of original designs all the time, because that just goes beyond what was really feasible to do, among other things. And I did have some constraints. First of all, I did not want to use any pre-generated rooms. A lot of the ideas came from playing around with a level generator for Doom called Oblige, mostly with the version 3.57 or 3.57. There was a version 4.x, that added a lot of pre-generated rooms. They looked cool, but very quickly you found you were just seeing the same room over and over again, and I didn't want that. So I needed something that would generate all its geometry at runtime and not rely on prefabs that you would, maybe see once and think, oh, this is cool, but then you see them the 10th time and it's like, oh, I've seen this so many times I don't care anymore. Why is it always the same? That I did not want. So it had to be deeply procedural and able to generate all room geometry. It also had to do this quickly at runtime in order to avoid lag. It needed to create the entire dungeon in a single frame and hopefully not create a huge lag spike. So it had to be done very quickly because it was being done while someone was playing the game. And of course, since Doomlike Dungeons was for Minecraft, it had to be something that would look good in a block world. And what I mean by that is, it couldn't have things like diagonal lines and curves and circles. Yeah, someone who's a good builder might be able to build like some kind of huge castle wall that looks curvy and looks really good in the distance. But these rooms are, generally not more than 30 blocks across, usually a lot smaller, and you're inside them, so you don't really have the range to create that illusion of curvature. And so in turn, that means everything has to be based on walls that align with the world axes. So squares, rectangles, that sort of thing. So the way it generates dungeons has 3 stages. There is a planning stage where it works out the layout of the dungeon and the rooms and what should be in it. There is a quality control stage, which wasn't around in the very early days, but was added quite a while ago now, to make sure all the rooms were passable, as in there was some way you could get from any room that you entered it from, you would get to one of the other rooms, as well as to make sure it was connected, so there were no chunks of dungeon that weren't connected to the rest. And then there's a building stage where it actually builds it into the world. And these are 3 distinct stages. And in order to do the planning, it uses a 2-dimensional matrix. No, a 2-dimensional array, which acts as a kind of matrix of code numbers, and it has a variety of numbers you can see here for things like floor height, ceiling height. It has a room ID, 0 being the null room, meaning outside the dungeon, and then 1 and further being different rooms in the dungeon. It has the ability to keep track of whether or not it is part of one of the routes that's calculated in the quality control stage later on. And there were originally a bunch of Boolean arrays that tell things like if it was a liquid, if it was a door, and so on. These later got compressed into this bool bits, where each one is 1 bit in a byte, and so all those got compressed into 1 byte that way, or 1 byte per grid in that matrix. In addition, some things such as spawners, chests, and some information about the type of room, such as if it has an entrance or not, if it is a room that may have a boss chest, are also stored with the room and looked at based on their room ID. But before we can place a dungeon, first we have to know where the dungeon is. And this has been done in several ways. Very early in development, this was simply a random chance per chunk. And this didn't really work very well, because you'd go on and on and on and not find a dungeon, and then all of a sudden you'd find several of them just by dumb luck right next to each other. Completely different dungeons, but all in the same place. So I devised another system which most versions of Doomlike Dungeons use. And it divides the world into large squares. This is determined by the config file. And for each of these square areas, and you can see the picture on the side, that's one of those squares, and inside the smaller squares are chunks. It will find one. It'll place 1 dungeon within each of those. Now, they could still overlap. You could have two of them in corners next to each other, but it tends to make them much more evenly spaced, but not completely evenly spaced. There's still a lot of randomness to it. So you can't necessarily guess exactly where they'll be, but they won't be all clumped together with huge areas of no dungeons. They will be more evenly spaced this way. And that's how most versions do it. Now, some of the new versions for newer Minecraft versions just use the vanilla structure system, so none of that really applies, even though I suspect the vanilla structure system in the new versions of Minecraft actually do something fairly similar anyway. But here we have some of the actual code for, I think this is the version for 1.12.2. And it uses these numbers. If I go here, it uses these numbers multiplied by chunks and the factor of how big those squares are. So this kind of turns the chunks into a bunch of chunks into one area and multiplies by this to get a seed for a special random. And it uses that, and it uses modulus or remainder, to find where within this square it will randomly become a 0. It will be one row and one column within that square of chunks will be, each will be 0, and where they're both 0, that's where a dungeon will be. So, for the planning stage. The planning stage actually is 2 different processes. And these are kind of interleaved together in that as it places a room, it then designs a room before going on to place the next room. But these are 2 separate processes. In theory, you could come up with a place for all the rooms and then plan them, but this just seemed like a simpler way to do it. Just plan the rooms as you place the rooms. But they are essentially 2 different things. And I didn't really have a name for them originally. When I first started working on Doomlike Dungeons, there were literally no books even available on procedural generation. I was kind of figuring it out all for myself, and I just figured out a way to do it, and I didn't name it. But I did figure I needed a name for these things, and I'm going to talk about them. So I figured a good description of the way I place rooms would be seeded growth spreading, because it kind of finds a place where it's represent a room that kind of seeds the room there, it grows, and then the rooms kind of grow to each other, the initial rooms that get placed randomly, and then they spread randomly after that. And then there's a room planning phase where it determines the layout of the individual rooms. And I've decided a good description or name for this might be shape modification stacking. Not stacking modifications, but stacking modified shapes. But if I, call it something like modified shape stacking, then someone might just as well think it was modifying shape stacking. So shape modification stacking is what I've decided to call it. And I don't know if anyone else has come up with the same or very similar ideas and giving them different names. This is just what I'm calling them. I kind of just made them up when I was making Doomlike Dungeons and worked out that this is what works. But before we can do this, either of these things, we have to figure out some core general features of the dungeon, meaning its size and theme. So, in most versions, the theme is selected based on the biome, and there can be more than one theme per biome, and a theme can be applied to more than one biome, but you have biomes kind of matched with themes. However, and you can see there's part of one of the config files where it lists the biomes that an urban dungeon can be in, as well as some biomes it should never be in. This isn't really done in the new versions for Minecraft 1.4, 1.19 and beyond, but for 1.12.2 and earlier, this is what it does. And by the way, these themes you can modify, you can remove them, you can add them. So it has to select a theme. The theme does influence the size, among other things. So the theme includes a lot of things about the types of blocks, what types of architectural features, such as pillars and sub-rooms inside of rooms, and so on. How often you find those. And the size is also, the different sizes it could be in are also determined by the theme, unless you use the config to set always huge, which you can do. So here we have from the config file also how you would list some of these things. And the numbers you go across them are none, some, about 10%. No, none, 0. Some, about few, about 10%. Some, about 30% of the time. Many, about 50% of the time. Most, or often, I don't remember what but about 90% of the time, and then 100% of the time. You can determine how often you'll pick these things. And this was done this way so that you could say that certain themes are more likely to have certain types of features, and also so that you could not have them, so you could have a range of features, because you could just say, hey, all dungeons 50% chance on each of these features, and Some of them, by luck, will have more or less, but it's going to kind of all peak toward the middle, and I wanted to be able to spread things out more. And again, to be able to make certain types of features more common in certain types of dungeons. And also, you can determine the mobs there. Now with vanilla, they tend to all have the same mobs because there weren't that many hostile mobs to deal with. But if you're using mods, then yes, you can put different modded mobs into different themes based on, put the swamp mods in the swamp dungeon and the desert mobs in the desert dungeon and things like that. As for the size, there is, as previously stated, there is a config option for always huge. Otherwise, this is based on some percent chances based on the theme. They come in a variety of sizes, so let me get the cursor back. And we have, this is how wide they are in chunks. And this is basically how their radius in blocks. And yeah, this is, by the way, is where I get that the largest dungeons are larger than the default view distance, because old Minecraft, the default was 8, now it's 10. Yes, a lot of people turn it up, but 11 and 13 are both bigger than that. You have the maximum number of rooms you can have in a particular dungeon. You have also the maximum size. The maximum size it can be on each, the X and on the Z. So how far across they can be as a maximum. When it's rolling its target sizes. And then you have the maximum and minimum number of what I originally called nodes, so that's why there's an N at the end. Nodes you might call hub rooms. Those are your entrances, and what some people like to call boss rooms is what they become. But those are the first rooms that appear, and they become the important rooms. So all this size data is in this enum, where it can be accessed by the generator to determine how big to make the dungeon and how many rooms it's allowed to have and how big it potentially could be and so on. So, getting on to the planning stage proper, the first thing we do is place the hub rooms, or what in code are called nodes. And once the dungeon is sort of built, these will, or as the dungeon is built, these will become either entrances or what one YouTuber described as boss rooms. You could also call them destination rooms or loot rooms, because they have a harder spawner, not necessarily a true boss, but a harder spawner that acts like a kind of boss spawner, and they have better chests, and presumably they would be the destination. But thanks to that one YouTuber, I've taken to calling those boss rooms, and the other, of course, are entrances. And these are just kind of placed randomly at different parts in the dungeon as your starting points. And then they are connected. They could be connected a couple of different ways. There's what I call the dense connection, which is basically what many people in networking, computer networking, would call a mesh configuration, meaning every room tries to form a way of connecting to every other, or sparse, and which is more like what we call the spanning tree, in which, yeah, you can get to any one from any other, but they only try to explicitly connect to one other of the node rooms, but in such a way that you can get from any of them to any of them by going through at least one other, or one or more others if necessary. And I said a 50% chance of either, and this goes back to the variety thing. I didn't want to pick one or the other. I wanted there to be a lot of variety, so some will be connected differently than others. And so here we have an example of a dense connection where everything is connected to everything. And here we have the code where it simply goes through each node and connects them to the other. So it goes through all of them, and then the inner loop goes through the ones that haven't been connected. Because if you connected A to B, you've already connected B to A. So this is why it's coded in this way, but there's how it's coded. And then you have the sparse connections, which here you have a few examples of how sparse connections would be. And then you have also the code for that, where what it's doing is it's putting one, creating two lists, one that has all of them that aren't connected and one that has one for the ones that are connected, and you randomly move one from the not connected, pick one from the not, you start out with one in the not connected, in the connected list, and then you randomly pick one from the unconnected list and connect to that one. Then you randomly pick one from the connected and connect it with a random one from the other, from the not connected, and move it over until they're all of them have been all those that were start out unconnected have been connected to one particular room. I know. Yeah, that's why I wanted to have these graphics. I know the way I describe it might sound confusing, but if you see what it's doing, it's pretty straightforward. And again, it's just connecting one that hasn't been connected yet to one that has been connected yet until all of them have been connected to one of the other rooms. So how are the connections made? And this is what I call the growth cycle. And basically, each room each of the two hubs that are trying to be connected, the two nodes, will start adding rooms. They'll take turns so that neither one is kind of being favored. And they'll do what's sometimes called a random walk, or alternately a drunkard walk or drunken walk, where they have a random chance of moving toward the other, creating a room that is closer to the other node in either the X or Z axis. And the probability is based on the distance. The further it is away on one axis, the more likely it is to move on that axis, but it's still random, so it still kinds to wobble and wander and not just move in a straight line. And so here is an animation. You can see it keeps adding. Each side adds a room, and the other side adds a room. And then when they meet, they're done. And every time it adds a room, that room is listed as being connected to the node that it came from. And if it runs into a room that already is there, say because you've already connected a different way, it will simply add that to its list if it runs into an existing room. And the way it knows to stop is when it reaches a room that exists, that it could add, but it already belongs to the other node, the other side. Then it knows, okay, I've made the connection and I'm done. And so after doing for all of the connections that you saw before, it would look kind of like this, or it could. And you can kind of see here's where we went before, and then this kind of went like so, and this one kind of merged into one of the rooms that were already there and then went up through there. So you kind of reused those rooms and added them to their own list of rooms until they met each other and were connected. After this, there's what's called I call the growth cycle, where it adds extra leaf rooms. These can sometimes create new connections. This is actually the first way, very early in development. This is the first thing that they did. That didn't really create good connections, so I had them seek out connections first. But after it's done that, it will add rooms through a system where every door that does not already connect to something has a chance to have it create a new room on the other side of it. There's not already room on the other side of a door, because as we'll get to when we talk about how the rooms are built, the rooms can add doors, and then rooms can be added beyond those. So any door that has been added to a room that doesn't have another room on the other side of it has a chance to create a room. If it doesn't, it's removed. Well, technically either way it's removed, but when those new rooms are created, any doors that they have that are not connected to another room get added back on. And so you keep doing that until you either reach the maximum number of rooms or reach a point where there are no more available doors. And here we have an animation of that. Add some rooms, add some rooms, add some rooms, and so you get this big complicated network with lots of branches, lots of loops, and lots to explore. Very unpredictable, very good for exploration. And just here's some of the code related to that. This is, by the way, all the code is on GitHub. And I will have a link to that if you want to see it, but this is just kind of, it shows it goes through until it is either out of rooms or the maximum size has been reached. Now, moving on to the beginning of laying out the actual rooms, the first thing we have to do is determine the room size. So first, it generates a random number for both the X and Z axis as targets for how big it wants to be on those, between 5 and whatever the maximum room size is listed for that dungeon size, because bigger dungeons are also allowed to have bigger rooms, not just more of them. Then it tries to expand and to see into that as a maximum. First, it'll expand along one dimension, or along one axis, to one block at a time. And if it runs into another room or the edge of the map, it stops in that direction. And it will stop trying to grow at all once it is run into a room or the edge of the map on both sides or has reached the target. After that, it'll try to expand along the other axis by entire columns that match what you've been worked out on the first axis. And again, there is an animation there to the side showing what it does, both a room alone and trying to move off another room with other rooms around it. And that way, it can try and fit itself in to the rooms around it, and at the same time not get bigger than would fit. It'll stop when it hits another room. It may not reach its full size if it's crowded in. It has to have at least 5 on each dimension, along each axis, because it needs 2 for the walls, and 3 is already pretty small. So at least 3 by 3 interior, which is at least a 5 by 5 room, is the minimum. If it's less than a minimum, it gives up and that room basically doesn't grow. So you don't get a room if there's not enough room for a decent room. And it will choose randomly whether to expand along the x-axis or the z-axis first, because that can lead to differences. If you look here, and this one, it started out going this way, didn't reach its maximum, and then when it started expanding the other way, it ran into these, and you got this shape. Whereas in this version, it went along this axis first, it got stopped here, but this, it went onto its full size. Damn it. Full size, and then back across, and then when it tried to go this way, it ran into this. So you get 2 different size and shaped rooms based on which way it went first. And to avoid it being biased toward one way or the other, again, it's a 50-50 chance between whether it'll try the x-axis first or try the z-axis first. The next thing it does is it starts piling on shapes or modifying shapes. And when it does this, it also uses symmetry. Symmetry is important because it helps it look designed. Gives it the it makes it have an appearance that gives the impression that someone must have built this for some reason, even if you would have no idea why. And there are a variety of types of symmetry, which I've kind of listed. And what it will do is it will check the theme's symmetry chance twice and add 1 for each time, and depending on whether it was 0, 1, or 2 depends on how much symmetry. So 0, none. 1, basically 1 plane or 1 level of symmetry, and 2, you'd have 2. And it can come a variety. And by the way, when it does this, it basically does this by, when it places a block in one place, it places places the same block somewhere else, so it mirrors. So here you have X, it can mirror along the X, or the Z could mirror along both. It can also rotate, so it'll take this F shape and rotate it 180 degrees, which we call rotational. Then there's the swirled symmetry, which is 90 degrees. And since if this gets around enough, someone's bound to bring it up. Yes, this is the same symmetry that a swastika has, which also begins with SW. That's not what that stands for. I have no way of, even though I've never seen one, generate in a dungeon after being through hundreds of them, at least. I suppose it's hypothetically possible, so if you ever do see one of those, or anything else offensive, I have no way. Just remember, it's luck. There is no way of really stopping things like that. But yes, this is the swirl symmetry. It's 90 degrees, and it does create some interesting patterns. And predominantly things that wouldn't be a problem for anyone, but look very cool. And then we have the transpose symmetry, which works by whenever it places a block at XZ, it'll switch those around and also put the same thing at ZX. So here's our original F over top of itself. Here we have a couple U shapes. And what this does effectively is create a diagonal symmetry. It's called transpose because that's based on how you would transpose a matrix. If you ever study matrix math, even though because it does it in an abstract way, it can actually do it on things that are not square, which a real matrix only can be transposed if it's square. But the transpose symmetry is basically a diagonal symmetry. So you have a couple pillars, and you have this. So those are the symmetries it uses. Each room also gets a block theme. And it does a lot of things when getting its block theme. It may, potentially, actually copy one from the dungeon, because the dungeon has a default block theme, which is randomly rolled from the themes block. The theme has a block theme that is a bunch of random choices. The dungeon has a block. Dungeons and rooms, they have one block for each theme that get rolled off the theme. The dungeon gets a default one. So if the room, and so what it does is if the room grew from a previous room, which I would call the parent, it checks the variability in the theme from the dungeon's theme to see whether or not it should change. And if it should change, then it checks it again to see if it should change everything at once, or otherwise it will then separately check for each block type and potentially change a few blocks at a time. Otherwise, if it is decided to change, but not change to something random, it may change to the dungeon's default theme. Hub rooms do not have a parent, so they automatically go to this check for whether or not they should have random blocks or just inherit the dungeon's default theme. And if they need to check a parent, the dungeon will be their parent, its default theme. And again, I do that so that you can have variability through the dungeon potentially, but not just completely random everywhere. So if you have high variability, you may just get rooms that randomly change room to room. If it's very low, maybe the whole block, the same block palette may be everywhere in the dungeon or through most of it. And in between, if it's kind of the middle of the row, you will often find that you'll have a few rooms together are basically the same, but then one will change one or two blocks, and then later will change another 2 blocks and slowly shift a lot of times, at least until they run into something that came from another room. So once all that's determined, we start out by writing the data into the matrix. Remember that map matrix? So we assign being a wall to the edges by iterating along them, and iterate across the whole thing to set the floor and ceiling heights and the block for the floor and ceiling, as well as the block for the walls. Then you add internal features. And for this, you will check the dungeon's complexity from the theme. And if it passes a check and it gives you a true, it will add many small features. Otherwise, it'll use one whole room feature, one whole room shape that creates something like a big S or U or something pattern for the whole room. So the feature checks it can add include what I call a cutout, as in it cut part of the space out and turned into a wall, so really an internal wall. A depression, as in a lower spot. A platform is an array spot. A pool, where you have a little two lower and some water in. Then pillars, which are just one by one wall, but it also sets to a different block, the pillar block. And what I call islands, which are basically just subrooms inside the room. If it's a whole room pattern, it will be it'll either first change everything into a floor and then pick a shape to turn into a pool and pick a shape to turn back into a floor, or it'll fill the entire thing with walls and pick a shape to cut back out. So, when adding a feature, first it'll get the number from complexity, so that'll be 0, 1, 3, 5, 9, or 10, based on whether the theme had for that be sub-theme, because the themes are basically sub-themes. When it picks a theme for a dungeon, then it selects the exact values from that theme, but it will pick that based on the target complexity. All the potential features are put into a list. The list is shuffled for the room, and then it's iterated, and each feature has a chance. If that feature's chance comes up as yes, and again those are the same. The same chances from the themes. If that feature's chance check passes, if it comes up as true, then that feature will be selected and added to the room, and then we'll move on to the number until we try our 5, 10, 9, however many times. If it reaches the end without finding a feature, that feature will be scrapped. And this is done in this particular way, and in a way it gives the room kind of like a little theme of its own. But basically, this is so you don't have a constant bias for features that are consistently first in the list every time. So it's not like, oh, we roll for liquids first every time, so they're automatically getting dibs over walls or dibs over platforms. It will randomize the list for each room, but then it doesn't randomize it more than once per room, because that allows each room to kind of have a sort of flavor of its own, where some rooms may individually be biased to favor certain things based on the order that they were shuffled into for that room. And as far as the composition of the features, pillars are always one by one. Island subrooms are always rectangular. They're basically just smaller rooms that take up part of the main room. Everything else is based on a shape, and these shapes are mostly named after and vaguely similar to certain letters. There is also just kind of a square, but it gets represented by the letter X, because there isn't really a good letter that looks like a square unless you count something like an O, but that's already was used for something else. And these shapes, which are originally described as shape primitives, but just shape now, are made out of rectangles, which are originally called basal rect for basal rectangles, but then I just changed it to rectangles. And these are defined in terms of a 1 by 1 square centered at 0, 0. There is a very good reason for that. But that 1 by 1 square that you can see right here is what all the shapes are built into. So, for example, this U shape, you'd have this negative 5, 5 here, and then this would be negative 1, 6, because it's the third, so like negative 1.66666 or something like that. But yeah, and so that's how these rectangles are defined in relation to this square that represents the overall shape. And this 0, 0 is going to become the point in the room, the block on the room where this is placed. And the reason it's done this way is that when they're this way, you can rotate them. You can also flip them, and you can scale them. So when you build them into the plan for the room, you basically just multiply all these numbers by however many blocks in each wide and tall, wide or long, or however you want to cite it. How many blocks in each dimension the overall shape is supposed to be to get the coordinates. You can get rounding. You do get rounding for blocks, but but this allows you to take this and stretch it over a bunch of blocks. They can also be rotated, and they can be flipped. And it's not obvious with the U, but with things like, say, the F, for example, or an S symbol, they have a right and a left-hand version, and there's no way to rotate that F so that it will look like that same F if you just flipped it. So it'll both flip and rotate to get all the possibilities. And they are scaled. Their fractions are rounded to the integer number of blocks, of course, and then whatever they represent changes in floor height, changing things to walls, adding liquids. All of that has been written in based on the blocks based on the coordinates within that map matrix that represent columns of blocks in your Minecraft world. And each rectangle contains a method with code for how to build each type of feature, cutouts, pools, cut-ins for building the one shape rooms, and it just iterates over that area of the map, changing each block into each of those block columns to match, to have its feature. Each of the tiles, however you want to look at the tiles that represent block columns, get changed to have that feature. And then shapes work by iterating through all the rectangles that are used to build that shape and having them build their feature. There are also cave-like rooms. These work differently. They use a form of what's called cellular automata. There are many types of cellular automata, but this particular form uses a system where you generate completely random 1 or 0 for each of them. For each tile, again, I'll just call them tiles, and just remember, a tile represents the columns of blocks in the world, and it's one square on the map. But I'll add 1. And the classic way of doing this actually is just to count the tiles around the middle one and change it based on the result, the 8 tiles around. I went with just doing the whole 3x3 area centered on that, so I include the middle tile. And depending on whether it's above or below a threshold, and I have a random chance of having a higher or lower threshold in a different cave room, so some of them are denser and some of them are open, it will change that tile to be either a 1 or a 0, where 1 would be a wall, 0 would be a space, and that causes kind of them to clump together, so the walls clump together and the spaces clump together, and you generate something like this, and you perform this, and you get something like this, which is your caves. And then I'd kind of repeat some of this also to determine areas with inside these open areas that we have changes in ceiling height as well, so it's not just purely two-dimensional. As far as door placement, the number of doorways is determined by the subroom variable in the themes. Really, I should have called that doors and what I call islands. Islands should have been subrooms, but, well, that's the way I did it 12 years ago, so that's kind of the way it's going to stay at this point. But the subroom basically determines the number of doors, and the reason I call it subrooms is because the doors are what have a chance to create more rooms. So having more doors means a greater chance of having more rooms. These are placed at random locations along the wall. Symmetry applies, but the swirl symmetry, just to make things simpler, is treated as just XZ rather than a true swirl. And this symmetry is applied when you're applying the doorways within a particular room, but it doesn't necessarily end up in the final room because, of course, the doorways could be added from the other direction from a room next door. And doorways can be placed side by side to create longer doorways, longer openings. And then we have to determine spawners. Now, all that stuff so up to here is stored in that map matrix, those tiles where it shows, okay, this is going to be what the floor height, the ceiling height, the blocks where the floor, ceiling, and walls are, if it's a block, if it's a liquid, all that. Now we come to these spawners. And chests and spawners are actually stored as data with the room and not on that map. But for spawners, the way they are determined depends on what type of room it is. Rooms with an entrance will never have spawners on normal or lower difficulty. On hard or nightmare, they could have one spawner, but only one. Node rooms that do not have an entrance, remember, hub rooms, nodes, without an entrance, will have multiple spawners plus an extra spawner with a higher level monster that I refer to loosely as the boss. It is not necessarily the boss category, but is typically harder than the others, as well as a better chest on top of it. All other rooms have a random chance to have spawners, and if they do, that same random chance determines whether or not they have one spawner or more than one. So if you go here to all the difficulties, you can see if you have none, you will not have a spawner. But you can go basically, this is chances out of 10, so you could say 30%, 40%, 50%, 60%, 70%, that these will have a spawner. And if it does have a spawner, say here's a normal 50-50 chance that a particular room will have a spawner. If it does have a spawner, a 50% chance that it will actually have 1 to 4 spawners. Then to determine the difficulty, there is a maximum difficulty for a normal spawner and a chance to promote. So this is a chance out of 10 that it will make it into a harder type. And if it does, it'll try again until it reaches this. So it starts out as 0. So say at normal, it'll only go to 1 because this is basic mob, this is hard mob. So it has a 20% chance of moving it up to being a hard mob. And I probably want to change this. I don't know. But and then, this could be what I call the brute mobs. Would be 2. So on hard and nightmare, crazy nightmare mode, you could have brute mobs as just normal spawners potentially. For the boss spawner, if instead of 0, it'll pick another level. So this would be where that would start out, and it would go up to this maximum level. So for normal, it would actually start out as a hard mob, and it would have this 20% chance of becoming a brute mob. And that would be as hard to be on normal. On hard, it could go up to nightmare, and it'd actually start as a brute and go up to nightmare. On nightmare, it would start as a brute and could potentially go all the way up to being a true boss, like a wither spawner. There's also this blocks per spawner. This is actually outdated. In the process of preparing this presentation, I discovered this part of it was actually not working. I fixed it. In the process of fixing it, I also changed these numbers to actually much smaller numbers. But what this is doing is saying how many blocks you should have in the dungeon, or columns of blocks per spawner. And yes, the numbers are, if these numbers look awfully high, this was a mistake. They're much lower now. And some of the code has been changed. But this comes into the quality control phase. At this point, we're dealing with this. And also this, which tells whether or not you can have spawners in the entrance level. And yeah, I got ahead of myself because that's what I was just telling you. Not hub room, 50%. And this is... Yeah, this 50% I'm talking about for normal difficulty. 50% of one spawner, 50% of multiple spawners. Maybe. And or did I anyway? And again, a boss spawn always has more than one spawner, more than one normal spawner, plus it has the boss spawner. And if it's an entrance, it will never have more than one, and it will not have any spawner unless it's on at least hard. So again, I kind of got ahead of myself. This is the actual code for how it determines the mob level. It starts with for normal. It starts with 0. For boss, it may start with that higher number, has a chance to promote, and it'll have a chance, and it'll keep promoting until either fails to promote or reaches the maximum for the type of spawner it is, either normal or a boss spawner. So there's the actual code that does that here. Placement, it basically just places them in random locations. It also adds them to a list, and this is important for later on when we do spawner culling. The boss spawner is a little bit special. These others, it just puts them in a random location and has a 1 in 4 chance of putting on the ceiling instead of the floor. Boss spawners, however, will always be on the floor if not in liquid, and always in the ceiling if there's liquid. And it's very important that it's not on the floor, it's in the floor. It's the same, replaces one of the floor blocks and then puts the boss chest on top of it. So then we move on to determining chests. It will randomly determine the number of chests, and then it will determine the level of a chest, which the level of the chest starts out as the level of the hardest spawner, then it adds 1 if there's more than one spawner, 1 if it's a boss room. Remember, that's just a node room that without an entrance, that therefore gets a harder mob and a boss chest instead. +1 if the theme is flagged as hard, -1 if it's flagged as easy. These are basically things I put in, so like the swamp theme and the underwater theme are flagged as hard because you have to deal with being underwater or with waiting and possibly being slowed down. I don't think I have any flagged as easy, but the reverse. If you think one is extra easy, you could put that and have a -1. Or you could do this just to make one that has harder or easier monsters. Change the monsters in the theme to one lower and then add hard if you want to make one type of dungeon that was harder. And then there's a 50% chance of just randomly adding 1. If there are no spawners in the room, however, it'll always be 0. And it will also be a weak chest. Any chest found in rooms without spawners will be a weak chest. There are 3 types of chests. The weak chest just has a little bit of random junk. The normal chest has more gear and food and so on to heal. And the treasure chest is the one chest that in the boss room that sits on top of or underneath of the boss spawner. It has a bunch of gear, a bunch of healing items, and a bunch of treasure items or loot items in the configs. They can be things like diamonds or diamond blocks, or for if it's high enough level, it could be a unique item, or with a unique item with cheaty enchants on it, or or something else valuable like a beacon. And again, they're placed randomly. And that leads to stage 2, quality control. And you can see there are 4 main things: analyzing the doors, checking for passability, connectivity, and culling excess spawners. So early on, in fact, even some of the more early on, and actually for quite a while in the early days, there were a lot of doors to nowhere. Because if there was a door that didn't connect to another room and it didn't create a room during growth cycle, it was still there. And so you'd have this door-shaped area and there'd just be like dirt and stone behind it. And so it will go through and it'll check all those to see if there's a room on every door in a room, to see if there's another room on the other side. If not, it will remove it. It'll also see which rooms are on the other side and pick one door for each room that's connected to be the preferred door to that room. And that's going to be important with the next section, because that's the door we're going to make sure you can reach from other doors. So it will set a preferred door, and it'll also tell the room on the other side that that door is going to be the preferred door. So the rooms with the lower numbers that get added first kind of determine the preferred door on the room on the other side, because they will pick one and then they'll dictate to that one that it already has a preferred door. So that way the door from room A to room B and the door from room B to room A will be the same door. We'll pick them the same on both sides. Now after that, it has to determine whether or not the rooms are passable. That is, whether or not you can get through them, as well as whether or not you can get through the entire dungeon if all the rooms in the dungeon are connected to each other. And to do that, we use graph algorithms. I'm not going to go into a lot of depth on these because, unlike the other algorithms I'm talking about, I definitely did not invent these, and there's a ton of information out there on them. But just in brief, you have the breadth first search, which basically you look at everything within one step, and within 2 steps, and within 3 steps, until you find either what you're looking for or find everything. You have Dijkstra's algorithm, which works kind of similarly, but it's based on rooms that have, or technically graphs. In terms of graphs, these would be vertices and edges are the connections. But these would be where there are weights. It costs more to go along this edge to here than to go along another one to somewhere else, or maybe another one to the same place. And so what it will do is it'll keep looking at whatever will decrease the cost. You can think of that as the distance by the least, even though now you have a cost. So it's sort of like if this is along a clear road and this other one is through mountains or across a river, it might have a higher cost, even though they're both going the same distance. It'll look at the lower cost. And it'll keep doing it until it finds what it's looking for, and that'll be the path with the lowest cost. And then there's A star, which is basically the same thing, except that instead of just looking at the cost, it looks at an estimate of how far it goes. So use either the straight line distance, which is called Euclidean, A star Euclidean, or it'll use the distance on each axis, which is called A star Manhattan. And that's what we're going to use. But by adding this estimate, it's not always accurate. It could be leading you into a dead end, but this estimate makes it much more efficient. And at worst, it would be the same as Dijkstra's, but almost always it'll be better, and most of the time it'll be a lot better. So this is what we're going to be using for a lot: the breadth first search and the A star. Dijkstra's, I'm only bringing it up because it's basically half of A star. So for room passability, we take all those doors and we run A star Manhattan with a cost of 1 for simply moving that distance, and 16 for each change you'd have to make in order to go there without difficulty. So if there's a pool in the way, removing the pool, the liquid, that's 16. Raising the floor is also 16. If there's a wall, you have to make a hole through the wall. So that would be plus 16. So what this does, it will strongly bias routes that do not require the room be changed in any way. If there is no such route, however, it will find the way that has the least changes. And we are using, and because you can't walk between the corner between two blocks that are meeting corner, we're only moving along the X and moving along the Z. We're not looking at any diagonals, and that's one reason we're using the A-star Manhattan. Once we do that, we will follow the path back and make any changes necessary. If any changes are necessary, very often none are, but any changes that are necessary, we will perform in order to make that a walkable path. And we will tag that tile as being A-starred, and that will be used for other things later on. And we connect all the preferred doors in a way very similar to the sparse dungeon, because of the logic that if you can reach B from A and you can reach C from B, then you can also reach A from C by going through B. So we're going to try and do a similar thing to what we did with the sparse node connection to make sure every preferred door is connected to one other preferred door, and by extension it is implicitly connected to all of them. And this, by the way, is because early on there would sometimes be rooms that would be completely filled with walls or completely filled with lava. The walls are actually worse because at least the lava you can see that it's a room and you can see where there might be doors on the other side. You can sometimes still see this at rooms at the very edge of a dungeon that don't connect to any other room besides the one you're looking from. And someone might find one of these and find that there are only two other rooms. They're both completely full of walls, completely full of blocks, and so it looks like it's just a dead end. And that was a problem. And this basically takes what was a problem and turns it to an actual feature, because now that room full of walls becomes instead a bunch of narrow pathways to move through, a maze of narrow pathways instead of just a room full of walls. Whereas a room full of liquid, lava or otherwise, now you get a room where you have narrow paths over lava, and you can't get more doomed than that. You just can't get more doomed than walking a narrow path over lava while monsters shoot at you. So basically, yes, this literally turned what started out as a bug into an actual legitimate feature. For dungeon connectivity, there is another problem, because it is possible that those rooms, when those nodes try to grow together, that they might never actually find a place where they meet. They might get so close that they can't have a full 5x5 for a room, width 5 for a room, and then they move away and they never actually meet. So it is possible. It's rare. I've not seen it in a few years, but that is something that can happen. So it will use a breadth first. It will treat the entire room as a connected graph. The rooms are the vertices. The preferred doors are the edges, and it'll go and try to find every single room. If it can find every single room, we're good. It usually can. If not, then it does another type of A-star, a variation. It's the same kind of A-star, but it's just slightly different because of the weights, different method. And the fact that instead of staying within one room, this goes across the entire dungeon, even the null room, which is 0. And for its weights, if a tile is A-starred, meaning it's already been found to be a preferred path by the room passability phase, it'll be 0, otherwise it's 1. Normal changes are 16, just like they were when going through a room, when finding our way through rooms, and Moving outside the dungeon is plus 64 because we only want to do that at the very last minute as kind of a last resort. And it'll bind its way through much like before, changing everything as necessary. And if it leaves the room, it will convert an area it has to into a tunnel, like kind of a tunnel tagged as a particular special room. It'll be tagged as a room. It'll kind of look like a weird tunnel. I've not seen one of those in a while, but that's what it'll do. It'll add walls and some space in order to make sure you have a way to connect to that area of the dungeon where one of the nodes didn't connect to the others. And then you have thinning the spawners. This is the last to be performed of the quality control steps, and also the last to be added. This is something I added after going into a tiny dungeon with a modded Mithril War Axe that could one-shot the mobs, and finding I couldn't kill them as fast as they spawn because there are so many spawners nearby. The ultimate problem is that spawners are placed per room. However, the size of rooms is dependent on the size of the dungeon. So the smaller the dungeon, the denser the spawners tend to be. And in very small dungeons, you can have them way too dense. So I decided large was really good. And basically, what this will do is it'll try to thin things out so that the overall density of spawners through average density of spawners through the dungeon as a whole is about the same as it would be for a size large dungeon. So as the rooms are, in order to do this, as rooms are added, they add their spawners to a list, and they have their own list. But there's also a global list of all the spawners for this purpose specifically, and they will add their area in blocks, their area in the tiles or columns of blocks, to a counter. They'll keep track of just how much actual area floor the dungeon has. And then when the dungeon has been fully planned, the total area of the dungeon is divided by the blocks per spawner based on the difficulty that is essentially calculated to be the same average as what you'd expect to be the average for a large dungeon. There is some randomness. It technically will go between 80% and 120% of that with a nice bell-shaped curve. And in order to get, and I'll use this to calculate an expected number of spawners based on what it might be if it was a large dungeon. It will then shift that list of all the spawners and then shuffle that list so that it's not going based on, so it won't be all the ones from certain rooms at the end. They'll all be shuffled up, and then it will start, and then it'll look at how many are actually in the list, how many are calculated, and how many were calculated as an expected number, and every spawner above that connected number will be just removed. And that's why you have the shuffle, so it's removing random spawners from random rooms, not just all the spawners from the rooms at the end. And that way it thins the spawners. And that takes us to the final stage of creating a dungeon, the building stage, which we build the structure, and then we place the tile entities, meaning the spawners and the chests, and then we build entrances in. To do the building, I, early on, when I was creating this in the very beginning, added the D-block class. Now, when I was creating Doomlike Dungeons, I was creating it simultaneously for 1.5.2 and 1.6.4. 1.6.4 was the latest version. My favorite mod at the time, Mind Fantasy, was on 1.5.2, so I created it for both. Interestingly, 1.6.4 is the last version that Mind Fantasy ever, at least Mind Fantasy 1, ever updated to. And I originally thought, okay, I'll just put IDs and metadata in those tables, those 2D arrays in the map matrix. However, 1.7 was in development and had already gotten out that 1.7 was supposedly going to move away from block IDs and things like config, at least partially. I doubt there are a bunch of words or so on inside the region files, but they were moving away from using block IDs generally, and you would just have a reference to the block along with metadata. So what I did is I created a dblock class where I could put whatever I needed to represent a block. So for those versions I was working on, that was ID and metadata. When 1.7 came out, it became a reference to the block and the metadata. And now it's basically just a wrapper for a block state. But this has allowed a Doomlike Dungeons to have something consistent through all the different changes to how blocks are represented in code and in other various files. In addition, it gives a nice integer ID that I can put in those tables. And that ID includes everything I need to know about that block in the dungeon. These IDs are generated as the theme files are read. As it reads theme files, it creates a D block for all the blocks it finds, and if that D block is already known, it just kind of throws it out and uses and gives the theme the ID for the version that's already there. Otherwise, it adds it. So the IDs are kind of assigned in the process as it goes. And this works very well with the map matrix. Now I can have a 2D array of IDs that are specifically IDs for the type of block as it exists within the dungeon. In more recent versions, there's been the addition of block families, and block families build upon D-block class. Originally, it was all about the D-block, and the D-block had its D-block registry where it kept all the D-blocks. In newer versions, there is an In newer versions, you have an I block placer interface and an abstract block and D block and block families and are both in there, and they both get registered together. But the block family holds multiple blocks. Technically, it holds a list of technically it holds a list of D blocks, really, but it holds block states are wrapped in D blocks, and it will randomly pick one every time it places a block. And this way you can have things like the mixture of cobble and mossy cobble you see in vanilla dungeons, or you can make it crumble by putting or you see some that are crumbling, but that's because I have several types of stone brick, but I also have air listed as a potential block that it could be, so that leaves blocks out and gives it this crumbling look. So it is basically a list of D blocks. To build the architecture, it iterates through the map matrix, the 2D set of 2D arrays I call the map matrix, to place floors, liquids, walls, ceilings, all of that. If a room is flagged as sky, it won't build a ceiling, and it'll use one high fences in place of the walls. If the room is flagged as a degenerate, it will not replace air or water, unless it's a floor, and that floor tile has been tagged as a starred, so it knows that this is supposed to be a valid path through that room. And this allows things like caves, mine shafts, potentially even mods from other structures to kind of cut their way into the dungeon. And if a tile is a door, it will delete 2 blocks above the floor. in order to create. Nope, wait. It started out as 2 blocks above the floor. I think pretty sure now I changed it to 3 so the bigger monsters could get through. But it will. No, wait. No. I think it's. I'd have to look at the code. I don't actually remember, but it blocks 2 or 3, deletes 2 or 3 blocks above the floor, meaning it replaces them with whatever is the theme says counts as air. So if it's underwater, that could be water. Then to finish up, it places the tile entities. First, it places the chests, then the spawners. Note that it processes the spawners first when planning because it needs the information to place the chests, but the chest level and the spawner level have been stored, and so it just goes ahead and places the chests first when it's actually building. And it actually chooses the contents of the chest and the mob to be placed in the spawner at this point. So it doesn't plan what's the actual contents during planning. It places, but it also, unlike modern vanilla chests, it does not wait till a player opens it. So luck has no effect. Certain other mods that people want compatibility with might be tricky because it places items in the chest when the chest is placed as a block in the world. And by the time you reach it, its contents are already determined before you open it. But it is not determined during planning. It is determined while building, which is actually how vanilla chests work when I start working on it. But anyway, then it builds the entrances. It'll randomly choose whether it is a simple, a top room, or a ruin. The chance of it being a top room versus a ruin are based on the degeneracy. And you can also force it to always have top rooms in the config, though I think that also still leaves the possibility of being a ruin. The ruin is basically just a broken top room. It's not the same code that generates it, but that's what it represents. If it's not a top room, it may just be a stair or ladder that just goes down from like the middle of the field with nothing around it. As for the loot that's in the chests, the basic and weak chests get 1 category, that which will never be loot. The weak chests have a chance of having something from the other category. And the basic chests have 1 category, will pick a category, but it will sometimes add the other category and sometimes add 1 treasure item or a loot, what is technically a loot item in the configs. Treasure chests have a bunch of items from all 3 categories, including the treasure loot that normally is not found or is found very in small quantities in the other chests. It has the potential to have an epic loot item, which the other types cannot have. Technically, the item levels go from 1 to 7, but you can have a level 8 item that is an epic item. And the loot treasure chests also have a chance to have a music disc. So here we have our categories: health, loot, gear, health, and loot. The health tends to involve a lot of food. Actually, when I started working on this, I didn't really know how to make potions. As far as like make potions with code for the game. So I put in food because it made it so you could potentially heal, and then that became even better with later updates. But then I eventually learned to add potions. That's also why you find a lot of golden apples, because they were kind of in the early days I used them as a healing potion substitute because I didn't know how to add potions yet. Have a level chance. And each item, just as the chest had a random chance to be 1 higher than it might be just calculated from mobs. Each item has a random chance of being 1 higher, 1 level higher than the chest itself. Enchants are added to some items. Items that can be enchanted will have a chance to be enchanted randomly, and if they are enchanted, it will reduce the level of the item by about 1% per 7.5 enchant level. So it'll determine how many enchant levels to have, or how many enchant levels are currently represented, what percent by its item level, what percent to convert, and then it'll reduce the item level. So it might say change a non-enchanted diamond sword into an enchanted iron sword. And it does that essentially by treating it basically like you were enchanting it, though it has a 50% chance of allowing for treasure enchantments that you normally can't get. Now, one thing to consider is that most versions of Doomlike Dungeons built the entire dungeon all at once. Once it planned it, it immediately built it right there. And it would include building it into chunks that were already explored and changing those chunks after the fact. And also, it would build into chunks that hadn't been generated yet if necessary. And in the process, cause all those chunks to have to generate. In fact, the biggest cause of lag, it turns out, in generating a dungeon was from creating lots and lots of extra vanilla world gen by causing all those extra chunks to have to generate. Then, for 1.12.2's version, there was what I call the chunky update. Now, this was actually supposed to be something that would help update to newer versions than that. It actually didn't work, at least not for a long time. But with this, the dungeon would be broken into chunks. It would only build a chunk at a time. Once it was planned, the plan would be cached in a special hash map I created for this purpose, because the sort of vanilla Java hash map would have been much more complicated to work with. So I created my own hash map. The hashing is it hashes coordinates for its hash. So it stores them by coordinates, and it uses weak links, which basically means that they are there and can be accessed until they are garbage collected. Once they're connected with weak links, they can still be reached, unlike something that's deleted. But unlike a normal link, it can still be garbage collected. And so that way I'm not having to worry about keeping track of how long they should be around before I delete them. If you're just traveling through and generating a chunk and generating another chunk that might contain the dungeon, it'll probably hang around long enough that it doesn't have to regenerate that dungeon. But if you turn around and leave, next time it garbage collects, it'll delete that dungeon. And if you go back to that area again and generate more of it that didn't generate before, it'll have to do the planning phase again. So that's how the chunky update worked. And in order to do this, it also generates one chunk at a time. It also makes it more consistent in its interaction with other features in the world. Because say, if there was a mine shaft in the same area, with the old version where it built the whole thing at once, in some areas the mine shaft might generate into the dungeon, whereas in other areas where the mine shaft was already there because the chunk had generated first, the dungeon would be overriding the mine shaft. This way it's consistent how it interacts with other structures. And that's how the current 1.12.2, current versions for 1.12.2 work. Versions for newer Minecraft versions use the vanilla structure system and end up saving it actually on the hard drive through the vanilla as part of the game's save files through the vanilla structure system. Because that's how the vanilla structure system works. And so there, we're done. We have completed our dungeon. We built it. It's ready to explore. And that's basically all about how the dungeons are actually planned and built. I know I kind of got my tangle and rambled a few places, but hopefully I didn't make it too confusing. As for other uses, the same level generator is used for Caverns of Evil as far as the architecture. Now, Caverns of Evil has actual monsters just placed instead of spawners, so that's obviously different how it places that. It has a different number of levels of monsters, and obviously different monsters because it's a different game. It places items completely differently. It basically gets one item per hub room. The first two are automatically put into random rooms because those are the ones that can correspond to the entrance and the exit, and the others have an 80% chance of being in the hub room, 20% chance of something else. Health and ammo are based on using difficulty and how far you are in as far as the dungeon level of a game to determine what percent, along with another monsters, determine how much damage you're likely to have taken, or estimate the amount of damage you're likely to have taken, the amount of ammo you're likely to need to kill everything, and then factor in things about difficulty and level progression in order to determine how much slack to give you, and then determine how much of that how many health potions and ammo items to scatter. So that's very different. But the level, and of course it's not a block world, not a true block world, so the way it actually builds the dungeons is by creating big non-cube blocks to represent chunks of the dungeon, chunks of the levels. Like whole sections of wall and floor and so on. But how it plans the levels is the same as Doomlike Dungeons. In many ways, it's Doomlike Dungeons the game. I've also considered that I kind of flip-flopped on the name I'm going to call it here. I say procedural growth spreading but I kind of changed my mind. I like seeded growth spreading is more descriptive, so I'll just say seeded growth spreading, as I've decided to call it, could be used as other things. It could be used with other room generators, such as maybe something based on pre-built rooms, if you had enough rooms the right size, or based on that wave function collapse stuff, or whatever other you could use other types of room generation for the actual rooms, and then use the seeded growth spreading to place the rooms, and use a different room generator to actually build rooms. And it's also occurred to me that you could probably use it for other things besides dungeons. For example, maybe you could use it to make a town or a village, where instead of rooms, each thing you'd have to change your scale, of course, but each room would become a lot that it could place a house on. And then the walls could be turned into something like paths, or maybe walls that have a room on both sides specifically could be paths. Or you could maybe extend it out further and have one that does a small number of rooms on a huge scale to create districts in a city, and then those districts could contain smaller seeded growth spreading areas to represent buildings. So you could probably do a lot of other things. So either by combining it with other room generation systems, or by using it for something that's actually not a dungeon at all. But anyway, for anyone who's listened to all this, I hope you found it interesting and informative, and that you have a great rest of your day and your week.